Hello, everyone. Welcome to the March 18th, 2025 SIG Node meeting. We have two agenda items today. Starting us off, we've got Tim.
Yeah, hi. So this is sort of a last minute change that we're considering to in-place pod resize. I say last minute because presumably it's going to beta this release. I'll probably send that PR out later today. It came up when discussing some use cases for in-place pod resize, and there's an approach to trying to make basically atomic changes to, or take like a snapshot of node resources frozen by using a no schedule taint. I know this is like a bit of a hack because, things can always tolerate that taint. But they were doing this previously and basically using no schedule to prevent anything new from being scheduled to the node. And the problem is that in-place pod resize basically breaks this approach because now, even with no schedule, you can still have things resized to take up more resources. And even if you block even if you put a admission controller in or something that says resizes aren't allowed right now, you could still have a kind of deferred resize from before that could get resized while that taint is present. And so we sort of were wondering if maybe resizes should just respect the no schedule taint. It's a little weird, I think. In retrospect, I think kubelet admission probably should have been checking for the no schedule taint. It's too late to change that now. There's actually, back in, I think, 2016, it was like Kubernetes 1.5, someone tried to add a no schedule, no admit taint, which basically does this behavior. That got rolled back. There's kind of still a like to-do, long-standing to-do in the API file to add that back. But question is like sort of we have a somewhat of a clean slate with in-place resize and have the option to check the taint when doing resizes. What this would look like is the resize would get marked as deferred as long as the pod that's being resized didn't tolerate the taint. And one advantage to this approach is there's currently a race condition with the scheduler, where if a pod is being scheduled to the node at the same time as a resize is happening, the pod being scheduled to the node could end up being rejected. And this is because resizes don't go through the scheduler. They're not synced to the scheduler. And we've had some conversations around like how to resolve this in the future. And there's some possibility that, resizes could end up being a sort of scheduled thing, which would make it more consistent to have this taint present. So I just kind of wanted to like open the discussion, like interested in feedback. Does this make any sense, or is this just kind of adding in, some kind of weird corner case here? Yeah,
thanks.
Go ahead.
One thing I want to clarify. So is this the case where someone is bypassing the scheduler and assigning a node directly to a pod with a no schedule taint?
I think so. I'm actually not sure if they're scheduling it directly to the node or just like using the nominated node, so it does go through the scheduler and tolerating the taint that was added.
So I'm talking about the case without the pod resize. So what
Yeah.
How exactly do we get into that situation? I think what you described for the resize makes sense. We're trying to understand like what the tech debt was from earlier.
Sorry, the tech debt. Do you mean what I was talking about with using no schedule in kubelet admission? Yeah, I don't know all the history there. I can share a link to the PR that originally added the no schedule, no admit taint effect. But yeah, it's kind of a, I'd say it's been a long-standing source of pain from like node, through node isolation and security that you can always bypass the scheduler, which includes bypassing any scheduling like constraints around labels and taints and whatnot by just assigning directly to a node. And if the kubelet for pod admission applied more of those scheduling checks, then we wouldn't have that problem. But that's, it's too late to change those things. Like it would be a big backwards
Okay.
change to make that. So just trying to kind of provide a little bit of context there.
Yeah, I think Yuju is saying things along the same line. But I think it makes sense. So we can't change that behavior, but we can change how pod resize handles that situation better.
Yeah. Yeah, Soteris.
Yeah, I was thinking the use case, and then I was wondering, what if we could just create a new taint, like no resize, and then solve it in this level, and then we allow the people who create the pods to explicitly mention that.
Yeah, I did consider that approach as well. Adding a new taint necessarily adds a bunch of latency to release. So that needs to go through an alpha phase first. And there's a bunch of kind of corner cases around adding enum values anyway that we need to make sure it handles version skew and invalidation. So we could add that as kind of like the long-term approach to this, but that does mean that like we wouldn't be able to land anything in beta until like 134, maybe even 135, which means that if we go to beta with in-place resize in 133, there's this sort of gap where there's no way to actually prevent a resize on a node. Yeah, to Yuju's point, yeah, no schedule is only respected by the scheduler. The kubelet doesn't currently look at no schedule at all, so this would be a new behavior on top of no schedule to ignore or to defer resizes when in the presence of that taint.
Yeah, and understand the use case of this. Just trying to see, because we kind of expanded the meaning of no schedule to a new use case, and no schedule already doesn't cover all other use cases that may cause resource, I guess, competition anyway.
Yeah.
Yeah, Tim, I thought about your response, and then I'm just thinking out loud that I understand that for the long term might be suitable, but we also have to see the reality and we need to have it in beta. So I was wondering, do you think we could make it as an extra feature gate and somehow allowing both a short term and a long term? What do you think about it?
If we want to go toward, if we want the long-term approach of a no resize taint, I don't think we can add a no schedule, like have it respect no schedule just for 133 and then roll back that behavior in 134 or later. Like, I think if this isn't the approach that we want to take long term, then we shouldn't make the change in 133. And we can look at other options to prevent it.
Yeah, makes sense. Thanks.
Yeah, and like if we're talking about a long-term change, something like no resize, would a no admit taint actually make more sense? Or I guess that's the no schedule, no admit taint that was originally proposed. Kubelet does recheck admission for resizes, so this would mean it's it would apply to resize, and then it would also apply to pod creation, and so it would address the case where node name is set directly, or any kind of third-party scheduler that wasn't checking taints would still get enforced by it. But that's kind of a bigger conversation, so we don't need to have that now.
Yeah, and overall we probably opt in. Yeah.
Yeah. So I think I'm hearing that people don't really like this change, that it's expanding the meaning of no schedule too much and moving it from a scheduler only concept to a kubelet concept is not great. So maybe we'll punt on this for now, and in 134 we could take a look at the use case again and see if there's some longer term change that we want to make.
Yep, sounds like a plan.
Okay, thanks.
Great, thank you. Ed, you're up next.
Hi, everyone. So it's just a review request. So I have a PR and it's under review for some time, and I'm still hoping to get it merged like this week before the code freeze. And PR is about monitoring plugin connections. So it's related to all three types of kubelet plugins, device plugins partly, because device plugins, they have their own registration mechanism, and CSI plugins and DRA. So the idea is to like get some separate Go routines that are started when plugin is registered, and they are just doing basically application level pings, like sending get info requests to the plugins to actually monitor their health. And if plugin doesn't respond, then it gets unregistered. And then another thing that it does, it also monitors the sockets that doesn't belong to any registered plugins, and if they start responding to those requests, get info requests, then they are like automatically registered. So that's basically it. And what else? SIG storage guys actually looked at it, and they didn't do like deep review, but they more or less agree with the concept as far as I understood. So please have a look. I'm still hoping to get it merged. Thank you.
Yeah, and I reviewed it some time ago, and I promise I will review, if not today, this week for sure. So can you remind me, for DRA situation, if we noticed that DRA was unregistered and then it registered again, do we delete resource slices from kubelet and then wait for DRA to recreate them, or like we just like, is there anything else beyond re-registration that we do in when we detect the problem, or we detect that we need to reconnect?
Well, this implementation in particular is part of the plugin manager, so it's not DRA specific. And to my knowledge, yeah, well, it's up to plugin, because the DRA plugin actually publishes resource slices. So if it loses connection to kubelet and detects it should remove them. But this is kind of another thing. It's not done in my PR at all. So it just simply monitors gRPC connections to the plugin.
Okay, so basically making sure that when we need to allocate device, it will allocate it faster because all the connections are fresh and up to date, and there is no like broken connection that we just didn't have for a while.
Yeah, that's one idea, and another that we actually detect disconnects faster, because currently there is no way the kubelet would know that plugin actually stuck or even crashed, and it still kind of assumes that plugin is registered. So trying to send requests to the plugin. So, and it's kind of not the way we want to operate. We want to detect disconnections as fast as we can. So that's why like this monitoring.
So it's like a health check for the plugins, right?
Yes,
Yeah.
exactly.
Yeah, and I think the other one, Sergey, you're talking about, that's part of the seamless upgrade one, where I think the idea was to wait for 30 seconds before getting rid of the resource license. You could, I think Patrick posted a PR for that if you want to take a look.
Yeah, I saw that other one, but I'm curious if we need to duplicate this logic here and in Patrick's PR, because
yeah, there'll be some overlap.
Otherwise, we have like so many health monitors. Like I would assume that DRA plugin itself will self-monitor the health, so it detects this. Like if it hangs, then liveness prop or whatever mechanism you will use, likely liveness prop will restart the DRA plugin itself if it stuck. But then on top of it, there is like this connection monitoring from plugin manager. But then on top of it, there is like health monitoring from DRA thing itself. So it's like 3 levels of monitoring, which
yeah, we need to.
That's why I'm asking what this level of monitoring is ensuring to have. And so far, my only explanation is we will detect that plugin is not there faster, and it means that we will not attempt to allocate devices. Or like if you're allocating devices and plugin was removed, then we will re-register it. I mean, yeah, I'm trying to put my head around what good we're doing in this level of monitoring and whether we need to move it one level above or one level below.
This is the lowest level I can imagine. I mean, if we are talking, so it's done on gRPC level, basically. It's application level pings, but utilizing gRPC requests. And I'm not sure, but as far as I know, the Patrick's implementation, it doesn't do any health monitoring. It's just handling plugin upgrades.
I think one thing to compare, Ed, here is like if we simply add like liveness or readiness probes, as Sergey mentioned, like do we still have issues where kubelet is making calls and hanging because the action wasn't taken to either restart or remove the offending pods fast enough? What's this kubelet having to do the health checks?
Yeah, well, if we have liveness or readiness probe for the plugin, but yeah, that I'm not sure it's like full replacement, but yeah, that can help also to restart plugin if it doesn't respond, but that's on the plugin side, so we cannot actually force developers to do that, right? So what my PR does is that it implements on like this health checking on the kubelet size, which is a bit different. But yeah, I agree that if those probes would like exist in all plugins, the situation would be better, but maybe in some cases.
Yeah, this is like
not enough.
kubelet taking action that it doesn't hang if the plugin is not written well, I guess.
Yeah, or if it's stuck, and I don't know if it's still, for example, responses to the probes, but it doesn't actually serve any requests. So it depends on how probe is actually written. But in this case, like this independent monitoring done from the kubelet side would help to actually unregister it.
Okay. Before I just one final comment, like maybe we need to see how many plugins we can support and what the overhead is of running a probe like this before, like I think like Sergey has.
Yeah, I glanced over the PR quickly, and I realized that there is a use case for the specific PR, like for this layer of monitoring. So, like we discussed like 3 layers of monitoring, and for this layer of monitoring, the one of the use cases that we will cover is if sockets still exist, and then what happened is plugin somehow either restarted or like crashed and being recreated, and plugin decided for some reason that it's a different plugin now. Like maybe it's exposing different endpoint, like you know how getinfo returns a endpoint and device class and all these properties. So what this PR is doing, it will re-register plugin with a new endpoint, for instance. So if the array plugin decides that, okay, that socket that I used to expose before is no good any longer, I'll expose new ones, and kubelet will reconnect to the new socket, which is a good thing. However, one thing I wanted to make sure, and I will review again, I didn't look at this too close. So when I'm talking about Patrick's PR that detects the removal of socket, like Patrick PR will react on socket being removed completely. So somebody removed socket, and then Patrick will receive the remove signal, and remove signal will trigger resource slice deletion. I wonder if we need to have this remove signal sent to upper level to DRA level when we detect that connection to socket, like socket exists, but there is no DRA beyond like serving the socket any longer. So if we detect that, maybe we also need to send a remove signal back to DRA, and then DRA will unregister resource slices. So I think that may be a requirement for this monitoring PR.
Yeah, but mainly what it does, it detects non-functional sockets. So it basically it cannot say if it detects that socket doesn't respond, the plugin doesn't respond on the gRPC calls, it cannot send anything to it.
Yeah, and in this case, what I'm suggesting is we need to send a remove signal to DRA, and then DRA will remove resource slices. Otherwise, pod will be scheduled, and this pod will fail to register because there is nothing to admit this pod.
Yeah, that makes sense. but I think it should be done like separately, because this PR is kind of generic for all 3 types of plugins, and I wouldn't want
plugin
to
manager
add,
already have remove
like,
signal, right? Plugin manager will send remove signal when socket disappears. So I think we need to treat failed get info calls as a plugin disappeared. Maybe with a timeout, and this timeout is something. Maybe we need to only merge this one, or like that removal signal when Patrick finished with the grateful period for resourcialization.
Yeah, that probably makes sense. Thank you.
Laura?
Yeah, I want to go back a little bit to the concerns that are being raised about multiple levels of monitoring, because I think as we've been looking into this like reliability project in general, there's like several layers of indirection between like the DRA driver, the kubelet plugin, kubelet itself, like who's waiting for whom. And I think a lot of the ideas we have are related to like being like isolating which component has like the jurisdiction over what monitoring it can do. And I think like the direction we're going does involve like adding basically multiple layers of like everybody checking on each other a lot. So can you talk a little bit more about like what your concerns are about having like too many layers of monitoring going on, and what are the types of things that like would make us feel more confident that all those layers of monitoring are required?
Is it?
And this is a question I think generally not just for you, Ed, but
yeah,
like I understand why your PR is like very specific about like this jurisdiction of like kubelet and what it's capable of determining in terms of when plugins like go away in a very like general sense. And I think that is like a good direction. But I know like Sergey was mentioning about like having too many layers of monitoring, or Mrinal was saying about the overhead of having like lots of health checks. So I just kind of want to get more of a temperature check on how everybody feels on like the overall direction I feel we're going, which is like more monitoring of everything of each other.
I think the reason I'm talking about this remove signal back to plugin, what I really want to avoid is people scheduling something thinking that everything's working, but infrastructure is actually not functioning right now on a node. So they want to use this device and they see resource slices, but when they schedule something to use this resource slices, those resource slices no longer are there. Or resources no longer there because DRA plugin is not functioning. So I want to get it to the logical conclusion. Like, I mean, DRA self-recovery, obviously, like liveness prop needs to be there. Let's DRA to self-recover. Kubelet detecting and stale connections, obviously, like it's great to have like up-to-date connection. But the most important part for me is like get it to a logical conclusion that if kubelet knows that DRA is no longer available for him or for it, then kubelet will need to update the resource slice and tell that it cannot serve this resource slice any longer.
Okay, yeah. So, I mean, I think from Ed's PR perspective, that's like out of scope of what he was trying to address. But I do understand that that is like an overall concern for the kubelet plugin reliability. I don't know if that is like a hard blocker. Like, I don't want to make that be the hard blocker for this PR if we can independently agree that like this level of monitoring by kubelet to check on whether plugins have like a fresh are able to respond to get info is like valuable in and of itself.
And the idea of my PR was to actually, because on this level, we cannot say that if it's a permanent failure or it's just a temporary. And this why we are the implementation actually continues to monitor those sockets in case that plugin kind of is unstuck and starts to respond again. And in this case, it will be registered. So that's that was the idea so far. So that's why I kept the implementation kind of not dependent on any type of plugin. So all the plugins are supported. But I'm not against it, and it makes sense. The thing is that we cannot always say like what kind of interruption is this? Is it just a temporary thing, or it's so for this to understand, we probably need more effort on the array side to get this information.
I kind of agree with you, but if the array doesn't reply to get info, then it obviously infrastructure problems that needs to be exposed. That's a different level of monitoring that you're talking about. You're talking about like if devices are not available, then the array will need to update resource slices, but I think it's different. Like it's the array responsibility to do that. But if kubelet just physically cannot connect to the array, then kubelet need to tell API servers that don't schedule anything that uses the array any longer because it's not available.
Yeah, I understand that, but my idea was that like if it's not a permanent issue, that we don't need to do all of that, just like wait and monitor the sockets in a hope that plugin will get back to life again.
Okay, Murnal, I see you +1 on this. Do we want to include this as in Ed's PR that we have some graceful timeout and send a remove to plugin?
Yeah, I don't think the code should be too much. I think maybe we can just discuss on the PR if it's worth adding. And I think Patrick's changes were on way to getting much. So.
Yeah, but Patrick's changes react on a remove callback.
Yeah,
so we need
no,
to
I'm
send
just
this
saying,
remove callback.
yeah. No, exactly. I'm saying it's similar to that code path. So maybe we can reuse some of that code.
Yeah. Okay, let's continue in the PR. Thank you.
Thank you very much, Ed. It's very important and very good topic. And Laura also trying to summarize everything. I don't know if you've been on device manager group meeting earlier today. Yeah, so great work. Thank you.
Trying to get it going. We're all trying to get it going. Yeah.
Great.
Yep.
Thanks,
Thank
everyone. AJ, you're up next.
Yeah, I added one based on my observation on boom killer killing burstable pods in reverse size ordering. This goes against how the eviction order is handled today. Like when Kubernetes explicitly intend to evict pods in the order of decreasing size, memory utilization, we influence boom killer to make opposite decision. There was the issue that I think like it was 2 years ago, it was raised and it was discussed that this was understood and intended. I am not I'm not sure like why the reasoning isn't clear to me. One reason mentioned was that to prefer smaller sized pods to be killed. So wanted to understand the reasoning behind it more, and also should we include priority ordering if we still feel like size ordering is fine, like priority ordering in the case. This comes up from my testing on load testing some of the conditions, and in my case, like the system cluster critical pod was killed before an abusive pod. So what do we think about this alternative, including priority order additionally than just memory size? I think Sergey, you had commented on this before.
I can comment on sidecar issue and some thoughts of reasoning here, but I don't know the history. So like if you're really interested in history, maybe Ronaldo Don can comment here. So for sidecar specifically, the issue was that inside pod, you end up with different size containers. Like sidecars typically super small, and container itself is big and heavy. And what happens is because of this logic running on container side, on container by container basis, not by pod basis, we ended up being making Node very dysfunctional by killing all the sidecars, like let's say it's a Istio proxy, and we're killing all the sidecars first, making every pod like not functional any longer. Like every pod goes into not ready state because Istio is not there. And then after we done that, then like we start sidecars back again, and then queue the sidecars back again. So Node is constantly being in not ready state because we just evicted the wrong thing. So what we did in sidecar cap specifically, we called out this problem and we said that sidecars, when they declared as a sidecar as a restartable init container, we will mark them with the same with the same kill score as a pod they belong to. So this was changed for pod scheduling. So we don't end up in situation when we killed all the Istio proxies and like everything is unusable on the node any longer. With regards to history of why it was chosen, like I'm pretty sure that we didn't want to kill something big. Like if there is a big pod that consumes all the node, it's likely more important and more expensive to restart. But I don't know further than that and why we didn't consider critical priority to be like less likely to be killed or something like that. But maybe don't.
This is Dong. So can you define what's the smaller size? Okay, let me share what we have defined of the order. So we try to make that is the predictable. So the order, just like what you observed, it is the best effort burstable and then guarantee. But even like the amount of the burstable, they also define the order. It's not the size. If you think about the size, it is how much you are using your request.
Yeah,
I think that's the original defined, right? So because you ask for this is punish people, the work node only requests minimal, right? So but using too much. So you a lot of burstable. This is aligned with we punish best effort first, and then for the burstable, you have the request. Then we monitor your usage, right? That's the two reasons. One, it is a abusive of the system, right? So you didn't properly set up your request. Second one, it is the using more than your request. Actually, you're more guilty to cause this of the resource starvation issue from the first place, right? So that's why we punish those instead of the smaller size container. No, it's not. It's like how much you are using extended of the more than your request. Okay, then the last one you ask for why we didn't respect of the priority. Yeah, when we define quality of the services, and we want to have this priority, scheduling priority, but in the SIG architecture, nobody agree upon that one. So at the end, they introduced very late the priority. I mean, if you watch the old video, how many times I present of the priority important. But after that, we came back to the SIG Node. We discussed, everyone already respect the previous behavior. And it's really hard for us also to say some of the bad behavior burstable, because the daemon side, a lot of daemon side, that time is the static part, right? So they schedule minimal request and the majority, but using a lot of the resources. So that's why a lot of people feel we shouldn't change back then. We could, one of those quality of the service we did mention something we need to revamp of those kind of things, reconsider those kind of things. It is not the time to re-exam, but here's the history. We made a cautious decision, and even priority. That's because that priority is more is like the how we are going to. Originally, we introduced those kind of things. We want that is the common decision for eviction and preemption and scheduling, right? So all those kind of things. But at the end, when decided syswom which one to kill, there's the other reason. Yeah. Hope I answered your question here. Yeah.
Yeah. Thanks, John. I think my interest was that I think I wrongly used size. It was utilization. So when eviction order prefers to boot out a pod that's like heavily utilizing memory, then how we influence the system should be like acting the same order. That's basically like predictability for me, right? Another reasoning is that with C group V2, we also don't have the the memconfig notifier. That would mean that we would need to rely on the C advisor polling, which would be slower for eviction. So it's more likely that like when it is like a high rising pod, has to be handled by the system, in which case I would want the system to also be following the user intent, because user clearly specified I have a higher priority pod and I would need that to be protected over another lower priority pod. That's where I am coming at.
I totally agree with you. We should reconsider those kind of things. We do agree, revisit those kind of things, because initially when I first proposed the priority, the scheduling priority to the SIG scheduler, they don't think what they need this one, right? So after we proposed, that is after 2 years, we already have our eviction management. We already have our quality of the services. We do plan to revisit those kind of things, but back then, community don't see the need. But all your reason, I totally agree. I also want to revisit this one. We can totally change, but I want to say that respect the best effort, burstable, and guarantee that order. I hope we can reserve, and also why burstable. Some it is kill first because they are exceeded more they ask for. I think about that the order also makes sense. At least so far it makes sense for us. And so how to inject another dimension about the priority, we need to think about more. Yeah.
Got it. Thanks, John. I think I could create an issue and we could follow up discussions over. Thank you.
Thanks.
Yeah, I just wanted to mention that it may not be an easy discussion because it goes into this philosophical question. If customers are saying that something is system critical, but then don't allocate enough resources for the system critical thing, do we need to just trust this customer and say like, okay, we will try to get it someplace else, even though we don't really have it, so we will try to like steal it from some other pods? Or we need to tell customers that like, yes, it's system critical, but it doesn't request what it used. So please go ahead and update requests and limits for this pod. So I mean, it really goes back into like how much we can help customers cheat in terms of overcommit a node such a way that it's like customer want it to be guaranteed, but like never said it's to be guaranteed. And how much you want to just say like a little bit of overcommit is fine.
I think then we need to aside one, but to also bring that into perspective, when we are introducing swap, like we are opening up how much user can overcommit, right? So there's going to be like more memory utilization than system going to offer more frequently. And I would see that predictability offers some sort of reliability guarantee to the user. I think like your previous concern about sidecar killed over like a larger pod, making it like unusable, that makes sense. But we already have a feature where like, we can select for a group rather than a container that at least is configurable. Like if that symptom is observed, like user can correct that. But yeah, we can follow up discussions on this further. Just got like overall thoughts on this.
Yeah, I'm just saying that unlikely we'll just say higher priority pods will have lower chance to be killed. It will be a combination of factors for sure.
Yeah, that's. I just want to also hope to raise one more point here. When those system critical pod, so sometimes maybe fail loudly, and then people will realize loudly and earlier, people will correct that instead and let them take over more and slow kill. And this is more like the SRE mindset. I just want to share. SRE mindset, not slowly creep to take away of the resource and slow down everybody. And I would rather fail loudly and earlier, so then we can take action immediately. Yeah, that's kind of another angle to look at some of those problems.
Okay, with that, we reach the end of agenda. If anybody else has any topics.
Just reminder, the code freeze is on Thursday evening Pacific time. So yep, work on reviews, paying folks for reviews.
Okay, thank you, everybody. Have a great rest of the
Thank
day.
you.
Thank you. Bye bye.